Hi guys, in this video we are going to start the topic atomic structures. However, instead of using this note, we are actually going to use another note which is like this. Now you can find this note from the description below this video, and I would recommend you to actually download it and print it out, and you will have it together with you while having this video lesson. Okay, so let's get started. Now, what we're going to do is we try to look into different elements and we try to be familiar with the name, its chemical symbol, how does it look like, what color it is it a solid, liquid, or gas in room temperature and pressure? And most importantly, we want to know the hazard nature. That means whether the element is dangerous or not. And if they are dangerous, what kind of dangerous nature does it possess? That means, is it flammable, is it corrosive, etc. Okay? So basically what I'm going to do is I'm going to show you the element one by one, and after that we are going to fill in the blanks, just like that, very simple. So let's start with the first one. Now, this one is aluminium, and this is the British spelling. In American spelling, you can put it as aluminum. Okay, so basically, you get rid of this I, then you have aluminum. This is American spelling. This is aluminium. This is British spelling. Both are acceptable in DSE, so just find the one that suits you the most. Okay, so aluminium or aluminum would be this one. Okay, would be this one. Okay, now every time I use a blank, okay, paper. Now, if you are smart, you realize that actually aluminum, this one is the cooking foil, the foil you use to wrap around the food item. Probably if you go to BBQ, you have those potatoes or taros, you will use this to wrap it and then you dump it into the furnace, right? So actually the cooking oil is made by aluminum, and this is how it looks like. So of course, judging from the appearances, this one I will put it down as silvery. Okay, silvery. All right, silvery color, and this is obviously a solid. Okay, and the symbol is Al actually, Al. This one you actually need to memorize it. Now, does it have any dangerous nature? Does it have any hazard? Of course it doesn't. If it is dangerous, then you won't use it to wrap your food item, right? So this is aluminium. Now, next one is calcium. So calcium, the chemical symbol is Ca, okay? And let's have a look at calcium. Okay, may not be that clear. I'll try to open up and show you. Okay, so calcium, again, it is a silvery or a little bit grayish, actually. It is not that silvery, so usually we call this one grayish, okay? So let's put it down, grayish. And obviously it is a solid. Is there any hazard warning labels? If you turn it over to here, okay? So we say that calcium is a flammable metal. So let's put it down, flammable. Okay? That means it can catch on fire easily. Okay, next one, copper. This one, the symbol is Cu. Now this one is a little bit different than the English name. It is not necessarily having the first two letters of the English name. Actually, some of the symbols are coming from the Latin word of copper. So the Latin word for copper, it is starting with Cu. So that's why the symbol is Cu. Also, the one that have the symbol Co is actually cobalt rather than copper. So that's why you really have to memorize it, the symbol. Okay. Now copper. So you see it has a brown color, and in chemistry we will call this reddish brown. okay, reddish brown. Now, remember, in chemistry, the color is very important. You won't say copper being brown, usually we say reddish brown. So I advise you to be more precise when it comes to the color of chemicals. So this one obviously is a solid and it has no hazard nature, okay? Now, starting from now, I'll speed up a little bit. Once you understand what I'm going to do, I'm actually going to speed up. Otherwise, it's going to be too boring. Of course, some of the elements are interesting. I will show you later. Now, this is iron. So iron, the symbol is Fe. Now, again, this is coming from the Latin word. The color is grayish. You won't say it is silvery, grayish. And this is a solid. Now, I will explain to you why some of them are grayish, some of them are silvery later, okay? After we go through all those metals. Now, the hazard warning label, well, it doesn't have any, so just cross it. Okay? Now, lead. Let's see, do we have a lead? Okay? Now, this is lead. I can actually pour it out for you to see. Okay, so this is how the lead looks like. Okay, so lead, the symbol is Pb. Okay, now the color, I would say it is grayish, and it is obviously solid. And what about dangerous nature? Now you should be able to see it very clearly from here, right? So lead, you know it is toxic. Okay, it is toxic. All right. So do not actually touch it. Then we have magnesium. Magnesium, actually, you have seen that one before. We actually did an experiment in Form 1 where we burned the magnesium metal. Okay, so this is how it looks like. So it occurs to me a little bit silvery, but some part is grayish. So I will accept both silvery and grayish. Now, first of all, this is Mg, okay? And I think it is lying between silvery and grayish. Actually, it depends on whether you clean it. If you clean it with a sandpaper, it appears very silvery. But if you didn't clean it, then it appears grayish, okay? So it is solid. What about hazard nature? Obviously, it is flammable. Okay, let's put it down, flammable. Okay, now, the other one, okay, the other one is silver. Okay, so silver, this one is all pieces of silver. Now, it's supposed to be much more silvery than this one. Those black things are actually the silver oxide. Probably this is very old, so that's why it kind of get oxidized a little bit. Okay. Now, silver, the symbol is Ag. And obviously, silver is silvery. So now you notice why I keep put down silvery instead of silver, because in chemistry, silver is an element. So when you say, oh, magnesium is silver, then it kind of quite confusing when it comes to chemistry. So that's why ought to put down silvery, okay? Now this is a solid, and obviously it doesn't have hazard warning label because obviously silver is used to make jewelries, ornament, right? You won't wear something dangerous on your fingers, right? Okay, next one is zinc, okay? Zinc, okay? Again, let's pour it out. Okay, so this zinc metal is kind of silvery, okay? But again, some of the old stock may get a little bit grayish. You see this white color here is actually silver oxide, okay? Again, this metal may be oxidized a little bit so that it has some white oxide on the surface. But after all, zinc is quite a silvery metal. Now, the symbol is Zn, and this is a silvery metal, solid, and it doesn't have any hazard warning nature. Okay? Now, for potassium and sodium, we can look at them together. This two is a little bit different than the others. Okay. Now, these two are the potassium and the sodium. Let's open up the potassium. So you see, now potassium metal, they are stored under some liquid, right? So can you guess what are this liquid? Now the liquid is actually called paraffin oil. Paraffin oil is a kind of oil that has, well, it's a little bit sticky and it is definitely unreactive. And you see the metal itself is kind of grayish, right? Kind of gray in color. Okay. Now you may ask, why are we storing it under the paraffin oil? Now the reason is because potassium metal is very, very reactive. It's a very dangerous metal. It actually reacts with the oxygen in the air to form potassium oxide. Actually, what you were seeing down here, the gray appearances, is actually due to the potassium oxide that is formed on the surface. So you can tell potassium, it is actively reacting with oxygen in the air to form oxide. Of course, we don't want this to be happening because what we want is potassium instead of potassium oxide. So that's why we want to cut away the contact of oxygen with potassium. That's why we have to put it under paraffin oil to prevent it from contacting with oxygen and also moisture, water vapor. Okay? Sodium has a similar feature. You see, it is also stored under the oil, and you see from the appearances, it is kind of gray in color. Gray in color. Okay? So let's put it down, the color and also the symbol. For potassium, the symbol is K, just K, right? And the color is grayish, solid, and actually it is a flammable metal. It catches on fire very easily. So let's put it down, flammable. Okay? Actually, sodium is also flammable. And it is also solid, grayish, and the symbol is Na. So these two are very similar. Now, we want to add a remark for these two metals. So these two, we say that they must be stored under paraffin oil. Okay, must be stored under paraffin oil. It is to prevent the metal from contacting oxygen in air or the water vapor in air. Actually, not or, and. Okay, and. All right. S, Na, and K reacts, okay, vigorously with oxygen and water. Okay, so that's the idea. All right. Now, so far we have been talking about all these. These are solid metals. You realize solid metals, right? They are all metals. And you can actually tell from the Chinese name, they are all having the gold prefix, right? The gold side, right? So they are all solid metal. And you notice some of them are grayish in color. In fact, most of these metals are silvery in pure form. In very pure form, they are silvery in appearances. The reason why they appear grayish is actually due to the oxidation due to its reaction with oxygen in the air to form oxide. And most of these oxides are grayish or white in color, so that's why it makes them look grayish. So if you have like very pure calcium, very pure iron, like very pure lead, they actually have very similar appearances as silver, which are all silvery. So that's the idea. Now down here, we still got one more chemical species, which is mercury. Now mercury, let me show you. So this is mercury. I try to carefully open this out. Now you see, it is even stoppered with cotton here. Well, it looks quite difficult to remove it because it's kind of like rightly fit into it, and I think we need to use a pair of forceps to get rid of it. So anyway, it's too dangerous. Just put it back. Now we can look at it from the side here. So it is a silvery metal. It's a silvery metal, but most importantly, you see, it actually is a liquid rather than a solid, right? It can float easily. So this is actually a liquid, all right? It is actually a liquid. So it's a silvery liquid, and it is stored under water, actually. It's stored under water, okay? And if you turn sideways, you will see this toxic symbol. So I think most of you know that mercury is actually toxic, all right? So let's put it down. So mercury here, it is having a silvery appearances, and it is a liquid actually, and it is toxic. Now, mercury here, this is the only metal that exists as a liquid and in room temperature and pressure. And you know, mercury is very toxic, so that's why it is stored under, just now, a couple of containers, and we also put it under water. The reason why we put it under water is because mercury as a liquid is volatile. It's volatile. So there's a chance where the mercury actually vaporizes to form the mercury vapor, and if we inhaled the vapor, it will be very toxic to us. So that's why we put it under water, so that less of this mercury will be vaporized out. And this is also the reason why we put this cotton here. Of course, we want to put the cotton here so that if the inner glass gets shaken, it won't get cracked. Okay, so this is like to secure it in the position. But it may also able to absorb some of those mercury vapor if they actually get vaporized. And also one more thing, a lot of you may have this question in your mind, like how do you pronounce this word in Cantonese? So this one is not gong shui, this one is pronounced as hong, okay? Hong. So the pronunciation is like this, okay? So very often we say mercury alloy or amalgam, they are called hong hap gam, okay? So that's the idea. Now, we haven't finished yet. We have just finished talking about all the metals. But at the back, we have another table showing you a lot of non-metals. So let's quickly have a look. Now, argon. So here, argon. Why is it a light bulb? Is a light bulb made of argon? Actually, no. The light bulb is made by the glass, it's made by the tungsten filament inside, and it has made by other metal pieces. But here what we are trying to say, argon, is actually the gas inside the light bulb. Okay? So do not ever say that the light bulb is made by argon. Okay? Actually, the filling gas of a light bulb is argon. Okay? So AR, and the color, obviously, it is colorless. And it is definitely a gas, and it doesn't have any hazard warning label. Okay? Next one is carbon. So carbon is this one, okay? So carbon, you can tell, is a black powder, black solid. I will put it this way, black solid. So it is C, it is black in color, it is a solid, and it doesn't have any hazard warning label, okay? Now, even though when we go to BBQ, we burn charcoal, and charcoal contains a lot of carbon, you won't say carbon being flammable, because when we talk about flammable, we say that it is easily catch on fire. But from your experience, you know it's quite difficult to start a fire with the charcoal, right? So definitely carbon is not that flammable. Now, chlorine here. Now, this one is a little bit special because we want to prepare the chlorine right now, okay? So to prepare chlorine, we actually need to do a chemical reaction. Now, the reaction itself, you don't have to know. But, okay, so here I have a big measuring cylinder. And to that, I'm going to add this one. Okay, this is chlorine bleach. Chlorine bleach. Let's open up. I'm just going to pour some into it. Of course, a chlorine bleach does not actually the chlorine. It just has a chlorine containing chemical inside. And what we're trying to do is we try to carry out a chemical reaction between chlorine bleach and hydrochloric acid. And the reaction between chlorine bleach and hydrochloric acid will generate a lot of chlorine gas so that you are able to see how it looks like. So now it may not be very clear, but you actually see the liquid here. Now this is not the chlorine, it is actually the solution after we add the hydrochloric acid and the chlorine bleach. And supposedly there are some chlorine gas at the top of the measuring cylinder. From my view, there are actually some yellowish green gas, a little bit yellow, a little bit green. But under the camera, I'm not sure whether you can see it or not. Probably it is quite difficult to observe, but actually there are some yellowish green gas, and those are the chlorine gas. Okay? Okay, let's put down the observation. So first of all, chlorine, the symbol is Cl, and the color, we say that it is yellowish green. Now again, it's quite specific when it comes to color in chemistry. Chlorine is not yellow, it's not green, but we say it is yellowish green or greenish yellow. So it is kind of in between yellow and green. This is a gas. And the hazard warning label, this is not a container, but actually chlorine gas is toxic. So that's why it can be used to kill the bacteria, kill the germs. Okay? Now, this one, hydrogen. So hydrogen, we have it here. So hydrogen. Okay? Actually, to be honest, this is just an empty container because hydrogen is colorless. So even though we fit in the real hydrogen gas, you are not able to see any difference. So yeah, this is hydrogen gas. So H, colorless, and it is obviously a gas. But hydrogen is known to be flammable. Okay. As a matter of fact, that our town gas, the one you use at your house for cooking, the town gas actually contains over 50% of hydrogen gas. So you can tell hydrogen is flammable. Now iodine, actually we did see this one before, iodine. So where it is? Over here. So this is iodine, and as you can see, it is sort of like black solid. Now you may see some brown color. This is actually due to the iodine sort of staining the surface of the paper or the inner side, so it appears brown. Probably some water vapor get in because iodine solution is kind of brown in color, but for iodine it's supposed to be black in color. It's a black solid. Okay, so let's put it down. Iodine, the symbol is I, so it is like a black solid. And iodine is known to be harmful. Okay. Now you may ask, what is the difference between toxic and harmful? Actually, I did talk about it during the first few lessons in Form 3. Toxic is more serious. Small amount of it is able to kill you or cause very serious health issue. But when it comes to harmful, it is basically less dangerous, so it will not be able to kill you. But if you take in sufficient amount of harmful substance, you may have some health issue. Okay, so that's the difference. Now nitrogen, of course, again, it is a colorless gas. Okay, actually you can look into the air. There are like 78% of nitrogen there, so it's colorless. It is a gas, and it does not have any hazard warning labels. Okay. Now for oxygen, it is O, and obviously you can tell oxygen again is colorless and it's a gas. And when it comes to hazard warning label, it should be oxidizing, but only when we talk about oxygen that is in very pure form, that is in compressed form. Okay, it's oxidizing. Now remember, do not put down flammable. A lot of you may think that oxygen is flammable, but actually it is not. Oxygen is used to support a fuel from burning. Oxygen itself doesn't burn at all. Okay, so it is helping people to burn rather than itself undergo combustion, rather than itself undergo burning. Okay, now phosphorus. Phosphorus is over here. Now phosphorus, if you look at it closer, it is a white solid. It's a white solid, and again, it is stored under water. Okay. The reason why phosphorus is stored under water is quite similar to the sodium and potassium, because phosphorus can react vigorously with oxygen to form phosphorus oxide, and this reaction is very vigorous and may generate a lot of heat, and there is a chance where the phosphorus actually catch on fire by itself. So that's why we store it underwater. First of all, phosphorus does not react with water, so that's why we can store it underwater. Just now for the potassium here, we store it under oil is because potassium reacts with water as well. So if you store it underwater, it will immediately react. But phosphorus, because it doesn't react with water, we can basically put it underwater. The key is to cut away the contact between oxygen and phosphorus. Okay? So phosphorus is P. Okay, the color is white. Actually, we have different colors of phosphorus. We have red phosphorus, we have white phosphorus, we also even have purple phosphorus, but purple is quite rare. It is a solid. And for hazard warning label, like I said, phosphorus, it can react with oxygen vigorously, so it is definitely flammable. And actually, when phosphorus reacts, it forms phosphorus oxide, and this phosphorus oxide, when it comes across with water, it can react with water to form an acid. So that's why it is also corrosive, if you can see it from here. If you can see it from here, okay, so corrosive, okay. Now, sulfur. So, sulfur is a yellow solid. You actually seen that one before when we have the sulfur and iron powder demonstration. We did talk about that before. So sulfur is a yellow solid, okay? And it doesn't have any hazard warning label, okay? Bromine. So bromine is over here. Now bromine should be one of the most toxic substances that you can find it in our lab. So bromine, you see, and you see actually there are 3 containers, okay? The innermost container is what we call a ampule. Basically, it's a glass container that is sealed off at one end. It's quite difficult to show you here, but actually it is a small glass valve or ampule containing the bromine, and you can see we use like 3 layers of glass to store it. You can tell how toxic it is, how dangerous it is, okay? But anyway, when you look at the appearances, we say that bromine is like a dark red liquid, okay? It's a little bit red if you look closely, dark red, okay? So here for bromine, Br, so it is a dark red liquid, okay? And it is highly toxic, very toxic, okay? Now, let's talk about the last one. This one, silicon. So this one is the silicon, okay? Large chunk of silvery metal, okay, silicon. So let's put down Si, and then it is silvery, and then it is a solid, and it doesn't have any hazard warning label, okay? So that would be all the elements that I need to show you, okay? Just want to fit in some remarks. So regarding some of the elements that we did talk about it before. For example, like phosphorus, you know, we store it under water, right? We store under water because we want to prevent phosphorus from contacting with oxygen in air, okay? Store underwater because we want to prevent phosphorus from contacting with oxygen in air, okay? And I just want to say one more thing, which is about the pronunciation of this. So this one does not pronounce as guai, it pronounces as guai, okay? Just like a turtle, right? Just like a little turtle, okay? Okay, think about it this way, just like a little turtle, okay? Guai, all right? Now, after knowing all these elements, there are a couple of remarks before we end today's lesson. So first of all, you notice we have classified them into 3 types of elements. So we have metals, we have nonmetals, and we have metalloids, okay? Now metalloids, in Chinese, is like this one, or sometimes we put it this way. Okay, so basically you can tell from the Chinese name, it is something that is similar to a metal, but it is not precisely or exactly belong to metal. So it's kind of in between metal and non-metal, all right? We will talk about this later when we talk about Unit 6, the periodic table. We will further talk about the difference between metal, metalloid, and non-metal, and like what makes silicon classify as a metalloid instead of just metal and non-metal, okay? So this is the first remark. The second remark is that when it comes to the chemical symbol, you notice some of them will have just 1 letter, some of them will have 2 letters. Now for those that is having 2 letters, remember the first letter must be in capital letter, the second letter must be in lowercase, okay? So like AgZn here. So that's why aluminium is not Ai, it's actually Al. This one is small letter Al, okay? And similarly for chlorine, this is Cl, not Ci, okay? Cl, okay? Iodine is obviously I instead of L, okay? So that's the idea. Now this worksheet, you need to keep it because later actually we will do this when we talk about topic 6, okay, the periodic table. So that's it for today's lesson. See you guys later. Bye bye.